Alright, so the next set of notes, we're going to look at sort of the behavior of graphs, understanding what the graph is telling you in terms of how is a graph growing and declining. Alright, so first, understand the difference between a smooth graph, because that's what we're going to look at, a scattered graph, and a line graph. Alright, so suppose we have the following information. We have the blood alcohol level as a percent, so 0, 0.05, 0.1, 0.15, 0.2, and the chance of an accident based on it. Again, these data you can actually find, usually this is what be insurance companies have this places because they want to know those types of information. Alright, so the percent chance of getting in an accident if you have said blood alcohol level. Alright, so then we plot the point. So this would be a scatter plot. Then, if we did a line plot, we connect the dots, right? You do a segment between each dot. Change the color just so you can see it. So we draw a straight line between the first two, and then a straight line between the second two, straight line, straight line, straight line. So they're all kind of segmented, right, when we do the line graph. All right, so then the difference between a line graph, where we're drawing a straight line between each of the points, so again, it's a straight line connecting the dots. That would be the line graph. A smooth graph is made from a scatter plot by joining the data points smoothly instead of line segments. So you're going to kind of draw a line smoothly between them. We're not going to stop between each point and draw a line segment. And so the example would be here, so there would be my line segments between my scatter plot. Then the last one drawn there would be the smooth curve that was drawn between. So this would be the smooth graph. That's the graphs we're going to look at. And we're going to look at and describe the behavior. So we're just going to go through a bunch of different smooth graphs and verbally describe the behavior of the graph. What is the graph telling us? All right, so we're going to visually examine the change, the growth, right? That would be the change, the growth in the graph, which means growth could also mean decline. Could be growth and decline. It would be decrease. All right, so the first one would be a line graph. A line graph means it's a constant rate. In this case, because we're moving in the upward direction, all right, it's a constant change. Anywhere on this line, we're moving up at the same rate. So this would be a positive rate of change. Positive average rate of change. That's the same through any points on the graph. Meaning no matter what points I pick, I have the exact same rate of growth. All right. In algebra, we'd say it has the same slope all the way through. Same change in y over change in x. Same growth rate through all the points. Same speed. It's moving up at the same speed. Right? Moving upward. Constant everywhere. All right, so the next one's an increasing graph, but it's not a constant increase. All right, increase because we're moving up, so it is a positive rate of change. All right, so it's a positive change in y over change in x. Positive. Anywhere we would find the average rate of change, it would be positive. However, it's not the same everywhere. It's different. In this case, the rates of change are increasing, and those are getting bigger. They're increasing. Right? The rates of change get bigger. Down here, if I picked the values down here and I found its rate of change, this would be a very small rate of change. Almost zero, almost no change. There is a slow growth. Eventually, if we go far enough back, statistically speaking, we would say it was a zero rate of change. All right, so very small. But then as I move up, notice it starts to get steeper, right? As I pick points as I move up this line. And so it's moving up faster and faster, right? It's increasing here. Again, a little bit faster than it was increasing down here. This was very small. This would be, maybe a slope of 1 or 2. Increases by 1 or 2 units. And then as we move up, this is pretty darn steep as we're moving up. And so it's a very fast increase as we move along the line, and it would get steeper and steeper and steeper and steeper and steeper as we go. And so in that case, it's a positive rate of change that's getting bigger. So it's increasing at faster and faster rates, bigger and bigger slopes. All right, next one is still increasing, so we're still moving up, but this time its rate is decreasing. So we're getting slower and slower. Still moving up, but it's moving up at slower and slower rates. All right, so it's an increasing rate of change. All right, so it is a positive growth rate, right, because we're still moving up. However, it slows down, right, as you move along the line, as time goes on, or whatever those numbers represent, it slows down. All right, the speed gets slower, the rates get slower. Right here, if I took my line, it's very fast. Right? It's almost perfectly straight up and down. That would be a very large rate of change. Very big slope, very fast. But then as I'm moving, my rate of change is still moving up, but you'll notice it starts to go slower and slower, almost flattens out down here at the end. So it's still increasing, but slower. Over here, the rate is almost zero, right? Because it's just barely moving up. It is moving up, but it's moving up really, really, really slow. And there might be eventually a point where it kind of just stops growing, and it is going to have a zero rate of growth. All right, very slowly once it reaches out. So it's increasing, but at slower and slower and slower rates, so it slows down. All right, so those are the increasing cases. Now we're going to look at the decreasing cases. All right, so decreasing means I'm moving down, right? So this is an example of decreasing at a constant rate. Constant rate is a linear case. It's a line. I'm moving down at the exact same speed no matter where I'm at on this line. Constant rate means you have the same slope. It would be a negative rate of change, all right, because I'm decreasing. And it's constant, meaning it's the same at any point on the function. No matter where I'm at, it's moving down at the exact same speed. It's decreasing at the exact same speed. All right, so we'll look at another decreasing graph. All right, so this one's decreasing, but at faster and faster rates. So again, we're moving down. It's moving in the downward direction. But it starts to go faster and faster in the downward direction. So again, it's decreasing, moving down, but at faster and faster speeds. So it's a negative rate of change. And those rates of change go faster and faster. Get bigger. Right? Because it's a faster decline as we move down, right? Here, if I look at it, it's fairly slow. It's almost zero here. It's a slow decrease. Slow rate of change. Slow negative rate of change. Almost zero. But then as I move down, it's getting a little steeper, a little steeper, a lot steeper, a lot steeper. And so again, it's decreasing, but faster here, right? Here would be almost zero. Here would be maybe a half of a rate. Here it might be a 1 or 2. And then here it's much faster. Decrease. All right, much faster rate of decrease. All right, so down here it would be losing, if this were losing population, your population would be declining way fast here. Much faster there, so something like maybe 30, and then down here would be like 100, right? Decreasing at a rate of 100, or whatever it is. So again, the decreasing, it's moving down, but at faster and faster rates of decrease. So you're decreasing, if this were money, you're losing a little bit at the beginning, and you're using a lot towards the end. All right, so the next example is the exact opposite of this. It's a decreasing at decreasing rate. So it's decreasing, but it's going to decrease slower and slower as time goes on. Alright, so it's still a negative rate of change, negative slopes, and they're decreasing at smaller values as you move on. So again, if I pick a value here and it's the speed, all of these are pretty dang steep. It's about here where I start to slow down, right? If this were, you're driving along in a car, this would not be a very good graph for a car, but this beginning part would be like you're going at like 100 miles per hour. And then you hit the brake somewhere around here at 5, and you start to slow down, and you slow down pretty fast. All right, you slow it down to where you're almost going at a 0 miles per hour. All right, you're getting slower and slower. So you're decreasing, very fast decrease. Your rate would be very big, negative. All right, it'd be something like negative, actually this is really steep, it would be like negative 100,000 at that point. Still pretty steep even when you're still here. It doesn't get to this point where we start to slow down the negative rate of change. Alright, so it's still negative, but a smaller negative. Right, smaller rate of change. So this somewhere around here, so if it was 1,000 up here, these would be something like maybe 50 and 100. Then here, it gets very slow. Almost 0. It's still decreasing, but it'd be decreasing like at negative 0.0001. Something like that. That's would be it's still negative. It's still negative. It's still declining. Just very, 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 very slow. Negative decrease. All right, the next example is sort of in a case where you can have both increase and decrease. All right, so this would be an example of a combination that has both average rates of change increasing and average rates of change decreasing. And so it's where the function's moving up and where it's moving down. So when it's moving up, it's increasing. All right, I've got positive rates of change. Somewhere around here, it actually stops and then switches direction. So here it's decreasing. So we get negative rates of change. And then looks like to be about 4 it stops. It would actually come to a stop and then switches to increase again, which it would have positive rates of change again. Here, I'm really big down here, and then it would decrease. Stop. Smaller here, gets bigger there, and then starts to decrease there, and this one would be increasing the whole time, getting bigger and bigger slope. So that would be an example of where the rates of change decrease. And I want to do a quick note at the bottom here, kind of talking about this stop. It does come to a stop, meaning there would be no change at that moment. And sometimes we can have graphs where there's like a bunch of places where there's no change. So suppose I have a graph like this. So a graph comes up, and maybe goes like that. That's my graph. And so that moment there, we'll call A, and we'll call that B. Alright, so increase, this is decrease. This one, when it's a flat line like this, that means there is no change. No rate of change. It's neither increasing, or a 0 rate of change, I guess I should say. As a 0 rate of change. No growth and no decay. So no increase, or decrease. You can read that. My pen's, it's being very, no increase or decrease from A to B. So whatever A to B would represent, it's flat. So there is no increase. It's a constant rate. Constant. It's at a constant level what we call horizontal line at that case, all right? So here it would be moving up, here it would be moving down, so positive rates of change, negative rates of change. This would have 0 rate of change, so this would be positive, 0, negative, all right? And again, some graphs do that, so do pay attention to that. When it's flat like that, that means there's no increase, no decrease, and so the rate of change is 0. All right, we'll stop there. We'll pick up the examples and the remaining notes in the next video.